So let's have a look at this bit here. So we have a look at this unit circle, and we have this right angle triangle drawn here. So the radius of one unit, and we've got this point P on the circumference of the unit circle, so that we have, with our understanding of sine and cosine within the unit circle, this length of this right angle triangle would be equal to sine theta, because that is our y coordinate. So that's going to give us that length there of that side which is opposite the angle theta. The side adjacent to that angle theta is cos theta. Now, if we just consider that right angle triangle and we remind ourselves about Pythagorean theorem, okay, then if we know that a squared plus b squared, so they're the two shorter sides of a right angle triangle, and we square them and add them together, that's going to give us the square on the other side, so on the hypotenuse, which is c squared. And if we apply that specifically to this right angle triangle, our a and our b are those two side lengths cos theta and sine theta. So if we apply Pythagoras' theorem to that, we have cos theta squared plus sine theta squared. That will equal our hypotenuse squared, and our hypotenuse is 1 unit, and 1 squared is 1. This here is called the Pythagorean identity, because it comes from Pythagoras' theorem. But we don't tend to write it with brackets around the whole sine theta and cos theta there and put the squared on the outside. It's just written this way, sine squared theta. So when we say sine squared theta and cos squared theta, what it really means is what's here, okay, of sine theta as a whole thing squared and cos theta as a whole thing squared. Because you can't square sine itself, it doesn't make any sense, okay? Sine is the ratio of those sides. Okay, so that's what we have there. Sine squared theta plus cos squared theta equals 1, and it is on your information sheet. Now, where do we use that? We tend to use it in problems like this here. Okay, so if we know that sine of some angle is equal to a value, in this case, this example, 3/5, and we know where our angle is basically located, so which quadrant it's in, okay, and that's what this part here means, okay. If x is between pi on 2 and pi, it means we must be looking at second quadrant, okay. So sine of theta is sine of x is 3/5, x is in the second quadrant, find cos theta, and then find tan theta. So we're going to use that Pythagorean identity. So sine squared x plus cos squared x equals 1. Now we know that sine x is equal to 3/5, so that means we can replace sine x with 3/5, and that then is squared plus cos squared x equals 1. Now we want to solve for cos x, so we're just going to bring our 3/5 squared over to the other side. So that means cos squared x will equal 1 minus, or I may as well square the 3/5, so that's 9/25. And so cos squared x will be, so 1 minus 9/25 will be 16/25. So just changing the 1 into a fraction of 25/25. So then we can subtract the 9 from that to give us 16. So cos squared x equals 16/25. We want to find what cos x is. So we need to undo that squaring bit. So cos x then will equal plus or minus the square root of 16/25, which would be plus or minus 4 over 5, and we take the square root of both the 16 and the 25. However, this is where that whole second quadrant bit comes into it, because we know that x is between pi on 2 and pi. If it's in the second quadrant, we know that cos must be negative. So that means we can just write cos x is equal to negative 4/5, because we know angle x is in the second quadrant. Okay. Okay, sine x being positive 3/5 works in the second quadrant because we know that sine is positive in the first and the second quadrant. So we've got cos x. Now how do we find tan x? Well, we know that tan x, or tan, is equal to sine over cos. Okay, so tan x equals sine x over cos x. We know sine and cos now of our angle x, so we can just replace sine x and cos x with those values that we've got. So that's 3/5 over negative 4/5. So we're dividing fractions. 3/5 divided by 4/5 would be the same as going 3/5 times negative 5/4. Okay, just invert the fraction and multiply it instead. So our 5's cancel, and we're going to be left with negative 3/4. And that works being negative, okay, dividing the positive sine by the negative cos, because in our second quadrant tan is negative as well, so it works that it's negative. Okay, so that's just how we apply the identities. We've got that Pythagorean identity, okay, the sine squared x plus cos squared x equals 1, and also this other identity where we know that tan is equal to sine over cos. Both of those, I'm pretty sure, are located next to each other on the information sheet. So that is pretty much all you'll need, that type of question when it comes to using that identity we just saw. So what I was thinking today is that there is an exercise relating to that. Okay, exercise 12L, so questions 2 to 5. I'm pretty sure works with that. You could work on that. You've probably still got a bit of work on last lesson stuff with solving trig equations. If you get through all that, then you can do a bit of work revising for tomorrow's test.